Hello everybody and welcome to video 5 in our right triangle trigonometry series. Today we're going to look at applying the trigonometric ratios. So we know everything we need to know about ratios. Now we're just going to look at solving triangles. Now what does it mean to solve a triangle? Well, to solve a triangle means to determine the measurement of all the sides and angles of that triangle. So we'll need to know all three sides in the end, and we'll need to know the measures of all three angles in the end. You'll be provided three pieces of information within the triangle and required to determine the measurement of the other three missing pieces. So they're going to give you three pieces, then you have to find three pieces. Let's get right into it. You'll notice that the information they give you will change, but based on those changes, we'll just make some decisions on how we want to solve these triangles. It won't be too bad. The first thing I'm going to suggest to you guys is something I like to do, and I actually got this from Miss Sandy Harasny, who showed me this a long time ago for organizing. So back when I was in high school, I didn't organize my work like this, but Miss Harasny gave me this tip, and I've liked it ever since. Just simply making a list. And this works with all kind of trigonometry. It's kind of a nice little thing to do. Anyway, so I know like angle Y is 90. I know now this, you have to remember that across here, that's the lowercase version of that angle letter, so that'd be little z, so that'd be 6. This guy then, this would be x, so that's 10. And then what that really tells you, it's just a nice way of showing what you need to find still, and then a nice way to organize your work. So like in the end, you can fill your answers in here, and then there's this little like answer box for you. It's got all your answers in there. So it's just a nice little thing. It is not necessary. Use it if you wish. You do not have to. Okay, so you can start wherever you want. Everybody will think through these problems slightly different, so you'll have something that jumps out to you. Some people might want to go with angle y right or side y right away, and they might think Pythagoras. Some might want to find x or z. Whatever you want to do is fine. I'm going to go with angle x first. And I don't have a good reason why. It just kind of jumped out to me when I was solving it. So for angle x, if I'm starting here, I'm going to name everything. And then when I look at that, this would be an opposite from angle x. And this would be an adjacent from angle x, meaning I'm going to use tangent. So tan x equals 10 over 6. Now, I just remembered something that I meant to mention in a previous slide, but right now is a great time to mention as well. There is a made-up funny kind of word that helps you keep all your ratios in order. It is SOHCAHTOA. And where should I write this? I'll write it up top. SOHCAHTOA. And what SOHCAHTOA is, well, this represents sine. Sine is opposite over hypotenuse. This represents cosine. Cosine is adjacent over hypotenuse. And the final one is tangent, which is equal to opposite over adjacent. So SOHCAHTOA is a made-up word that it's a nice word because it helps you keep those trigonometric ratios straight. So anyway, that's just a little detail. You don't need to know it, but I think that's a nice thing to know. Back to what I'm doing. Tan x equals 10 over 6. I want to find angle x. So inverse tan, remember we're telling our calculator to go backwards on its chart that's programmed into it. When you do that, you'd get 59.01 degrees. All right, and then I can go back here, 59.01 degrees. My question says to round all final answers to 2 decimal places, so I did that. All right, now angle Z I think I'm going to do. So at the start of this chapter, what we do for angle Z is we'd likely use tangent again. Well, we're deep enough in, whatever the shortest way to get your answer, whatever the shortest method you know, that's the way I'm going to get you guys to do it. So I'm going to use my 180 degree rule. That angle Z is equal to, because the three angles in a triangle add to 180, so I'm going to go 180 minus, first of all, the right angle, so 90 degrees, and then subtract the angle we just found, which is 59.01, and whatever is remaining, which is 30.99, that has to be what angle Z is, because the three angles must add up to 180, so that means that angle Z has to be 30.99. So there's a shortcut if you want to use it. Otherwise, you could have used tangent again. So now it would be tan Z equals 6 over 10. And you get the same answer. Or, yeah, you'd get the same answer, sorry. The final thing, now y. So to find y, I'm going to use Pythagoras. A squared plus b squared equals c squared. So now, how did I think of that? Well, I had these two sides right here, and I'm looking for this third side. So, and I guess not more importantly, but another important detail, it's a right triangle. So whenever you have 2 out of 3 sides in a right triangle, you can use Pythagoras. So that's why I thought of that. Truly, the solving isn't the tough part with any of these solving triangles. It's thinking of what to use. So once you know what to use, usually the solving, just takes some time, but you'll get it right. It's choosing the right methods and why. So I will try to explain why I'm choosing what I'm choosing. Anyway, back to this. A squared, so 6 squared plus b squared is 10 squared equals c squared. So 36 plus 100 equals c squared. I'm going to kind of flip this now. C squared equals 136. Why did I flip that? Because you want your variable on the left side at the very end, so I'll do that now. And then I got to take the square root of 136, which ends up being 11.66 centimeters. 11.66. And there we go. I found, I was given 3 pieces of information, my y, my x, and my z. Angle y, side x, side z. And then I found the 3 others, angle x, angle z, and side y. So let's get into example 2. Once again, you want to keep this SOHCAHTOA word rolling around your mind to keep things straight. And I think we're going to use our little list again. So K, M, N, side K, side M, side N. They've given me angle M, which is 90, side N, which is 7. So remember, when you're across, the side across from the angle, it gets the lowercase version of it, so that would be N. And then this is big K over here, so then this side has to be little k, so that'd be 11, which is meaning that I got to find angle K, angle N, and side M. And again, you can work through it on whatever order you want to do. So for me, K came first, so I just looked at K. All right, so to find angle K, I have these 2 sides here, here, and here. And if I look at it, this would be the opposite side of angle K, and this would be the adjacent. So what has opposite and adjacent? Tangent does. So I'm going to use tangent again. Okay, tan K equals 11 over 7. And again, once you know what you're using, so I know I'm using tangent, now the solving part I don't think you guys are going to have trouble with. Like I said before, it's more trying to determine what tools you're going to use to solve this triangle. So what techniques you're going to use to find angle K, angle N, and side M. Anyway, to find that angle, I got to go inverse tan of 11 over 7, which is 57.53. Make sure you're in degrees, everybody. So I can put that here, 57.53. You don't have to use that little summary table I have in the left here. This thing, just a reminder, you don't have to use it, but it is nice, I think. Angle N. Again, I'm going to use the same technique as last time. So angle N, if I know 2 of my angles, I can use this little trick to find the third angle, but I'm going to shorten it a little bit. I already know that this thing has a 90-degree angle in it. So what's 180 minus 90? Well, it's 90 right away, meaning that these 2 angles here have to really just add to 90. So I'm just going to do that. I'm going to go 90 minus the thing I know, which is 57.53. When I work that out, I get 32.47. And then 32.47 plus 57.53 then is guaranteed to add to 90. So I know that that has to be angle N. If you don't like that technique, then simply use one of the trig ratios, which again, in this case, you'd end up using tan again. Okay, so I've got 2 of them done. Now this side M. And for side M, again, I have 2 out of 3 sides in a right triangle, so I'll use Pythagoras. So a squared plus b squared equals c squared. It doesn't matter. I could make A the 7, or I could have made leg B the 7. Doesn't matter how you name them, as long as the legs are in the leg positions. So 7 squared plus 11 squared equals c squared. So 49 plus 121, equals c squared. Now I'll kind of flip that c to the other side. That adds up to 170. I'll take the square root of it. Square root of 170 ends up being 13.04. And once again, I've done it. I was given 3 pieces of information. I found the other 3, so now I know everything about this triangle, so therefore it is solved. C, we're just going to keep going. This one will be slightly different. D, angle F, angle E, side D, side F, side E. They've given me angle F. They're always going to give you the 90-degree angle, so that's one of them. They've given me angle E as well, so I know 2 angles in this one right away. And then this is E, and this is across from E, so that means this is the 5. All right, so I need to find angle D, side F. So the first thing I'm going to do is, again, I worked left to right, so I'm going to find angle D first. You don't have to find it first. You can do something else first, but I'm going to find this. And I know 2 out of 3 angles in a right triangle, so I'm going to use my 180-degree rule. So angle D, well, I'm going to adjust it to that 90-degree rule already, really. So I know all 3 angles must add to 180. But I already know F is 90 of it, so that means D and E have to add the 90. So really, if I go 90 minus the other one I know, which is this 25, then I get 65. So I know angle D is 65 degrees, and that one's real nice and quick. And I didn't use a trig ratio, and that is absolutely fine. Now, let's look at side D. Okay, so if I'm looking for side D, I got to really remember where that is. Well, that's going to be right here. Oh, my pen kind of quit working there for a second. There's side D. All right, so the other thing to remember is that we always work from the given angle. Well, they gave us this angle E, which is 25 degrees. So if that's 25 degrees, let's see what I have here. Well, this angle, or this side length over here, is the opposite. And this one that I'm looking for, well, that ends up being the adjacent. So once again, we've used tangent a lot, but I'm going to end up using tangent. So I would get tan of 25 degrees equals 5 over D. And the variable's on the bottom, which means it's actually one extra step, but not a big deal. So I'm going to set it up. I'm going to create this proportion, and then I'm just going to start multiplying. So D times tan 25 equals 5. Divide by tan 25, divide by tan 25. So D is equal to 5 divided by tan 25, which ends up being 10.72, and then I guess it'd be centimeters. I haven't been putting my units in. So 10.72. Okay, I found angle D and side D. Now I'll find side F. Okay, so let's flip to a different color. So side F ends up being right there. Okay, and again, you always start at your given angle. So there's my given angle. Now, based on that, now I wouldn't call that the, well, I guess, sorry, that is still the opposite. My bad. And then this ends up being the hypotenuse. So remember, we always have to lock in what angle we're working from, and then we start naming these sides. So opposite and hypotenuse. I forgot to write my little code word here, SOHCAHTOA. And which ratio works with opposite and hypotenuse? Well, I see opposite and hypotenuse right here, so that means it's got to be sine. So I'm going to use sine for this one. So sine of 25 degrees equals the opposite first, which is 5, over that hypotenuse, which ends up being F. So I have the variable on the bottom again, just like in the previous one. So again, it's just that little extra step, which isn't a big deal. Really, we have a calculator that does all the hard work for us, which is not very hard either. We're just finding things from a chart. Divide by sine 25. Divide by sine 25. Okay, F is equal to 5 divided by sine 25, which works out to be 11.83, and then centimeters, 11.83. All right, so that's 3 examples. Let's do just one more example. And again, I'm going to start off with my little list. H, G, and J. H, G, and J. H is 39. G is 90. We're going to be able to find J really quickly. So this ends up being side H because that is across from the big H, so that's 9. J, everybody, ends up being over here, and G ends up being over here, just so we know. And those are the other two things we're looking for. And you can start wherever you want to start. Again, I just kind of work left to right, so I always deal with my angles first. When I'm saying left to right, everybody, if you're wondering what I'm talking about, I'm kind of talking about I'm going to start in this column first, and I'd start at the top and work down, and then I'd go to the next column, and I usually start at the top and go down. But you can use whatever order you want. There is not an incorrect order. There are sometimes you'll see problems where there is a sequence you'll have to follow, like you'll have to find one answer first to get the second answer, but that's going to happen more in our the next video, which will be our 6th video. Okay, anyway, back to this, angle J. Okay, well, I know 2 out of 3 angles, everybody, so broken record. Now, again, the rule is all 3 angles have to add up to equal 180 degrees. So I can go 180 minus them, or I can just go 90 minus them because I know I already have a right angle, meaning H and J must add up to 90. So 90 minus 39, that equals 51 degrees. So there we go, 51. Got one out of the way right away. Now we'll go with side G, and again, side G is right here, so we have to work from an angle. So we're working from that angle there, and then we want to work with any other given side, right? So this ends up being my opposite, and this ends up being my hypotenuse. And how do I know that? Well, it's across from that right angle. And if I go with my word up here again, SOHCAHTOA. So what deals with opposite and hypotenuse? That is sine. So I'm going to use sine. So sine 39 degrees equals 9 over G. G times sine 39 equals 9 divided by sine 39. Why I'm dividing by sine 39, if you're wondering, is because I want to get G by itself. So to get it by itself, that means I have to move the sine 39. The way you move something to the opposite side is by performing the opposite operation. Initially here, this is the multiplication, it's G times that, so then the opposite would be division. So that's why I'm dividing, everybody. Anyway, then G would be equal to 14.30. And that is centimeters. 14.30. And the final side length that we're going to be finding, the final part of this video, I guess, I'll go to a different color. Again, I'm going to start with my angle, so I'm locking that in. I'm working from that one. This is still opposite for me, but now I'm over here looking at this guy, which is J. That ends up being the adjacent leg from this 39. So now I'm looking at, okay, what has opposite and adjacent? Opposite and adjacent, that is tangent. So we'll use tangent for this one. So tan 39 equals the opposite, which is 9, over the adjacent, which is J. And then, yeah, take my time, go through it and solve. So like I mentioned there earlier in the video, I think the solving part is easy. It's picking what tool you're going to use to find that answer. So it's choosing, is it sine, is it tan, is it cosine, is it Pythagoras, can I use one of these other kind of rules I know, like triangles add to 180, all that kind of stuff. Divide by tan 39. Okay, and then J is equal to then 11.11. Okay, there you go, guys. So that is how you solve a triangle. To solve a triangle, we have to know all the details in the end. They're going to give you 3, you have to find 3. And to find those 3, you use all the different tools we learned in this chapter, along with any other kind of math facts, like I said, which would be, say, Pythagorean theorem or the triangles add to 180. So I hope you had a good day, and I hope this video was easy for you. If it wasn't, make sure you talk to myself or get talking to your teacher. Otherwise, everyone, have a great night.